Here we're asked to factor x squared minus 9. Well, first thing I do is look for a common factor, and I do not have one. As a binomial, there's only one other way that this will factor, and it is if it meets the qualifications for what we call a difference of squares. Being a difference means that there must be a minus sign here because a difference is found by subtracting. Being squares means that each term has a perfect square root. The square root of x squared is x, and the square root of 9 is 3. The difference of squares factors as the product of the sum and difference of like terms. If you remember back when we were multiplying binomials, we saw that the only way we came out with a binomial answer was if we had a sum and a difference of like terms, meaning the variable in the front had to be the same, and the number in the back had to be the same, and the square root of 9 is 3, so we have x plus 3 times x minus 3. That comes out to be the binomial because remember your inner and outer cancel out when you've got the sum and difference of like terms. So in this product, once again, we look for a common factor, which there's not one. We do have a difference because it is subtraction. 4 has a square root, and so does x squared. The square root of 4x squared is 2x. 9 has a square root of 3, so we have 2x plus 3 multiplied times 2x minus 3, the sum and difference of like terms. In this problem, we actually do have a common factor. 3 will go into both of them, and also they share an x. So if I take the 3x out, I'm left with x squared minus 25. Now what I have, my binomial left in the parentheses, is a difference of squares. So I take the second step of factoring that as x plus 5 and x minus 5, the sum and difference of like terms. So my final answer is 3x times the quantity x plus 5 times the quantity x minus 5.